From shipbuilding yards to open seas, witness the fascinating journey of crafting, transporting, and launching mighty vessels worldwide. The procedure begins with preparing the worksite to receive the mold. The supporting framework and floor surfaces are thoroughly cleaned and leveled to avoid any misalignment. Next, cranes and hoisting rigs are attached to lifting points on the mold. These lifting systems are operated with extreme caution, as even a small imbalance could cause stress or deformation to the mold structure. Spotters and engineers guide the process closely, ensuring the mold remains stable during the lift. Once elevated, the mold is carefully maneuvered into its designated position. Workers communicate constantly, using hand signals and radios to synchronize movements between the lifting operators and ground personnel. Gradually, the mold is lowered into place and aligned with reference points marked on the workshop floor. Precision tools such as laser levels or measuring systems verify that the mold is perfectly aligned before it is secured. Finally, once positioned, the mold is fixed to its base with supports and locking mechanisms. This ensures stability throughout the subsequent production stages. Proper placement of the female mold is critical, as it directly affects the quality, accuracy, and durability of the final large-scale structure. The project began with the hull assembly, where the foundation of the vessel took shape through the joining of large steel sections. Following this, the bow module was constructed and set aside for later integration. At the same time, the stern module was fabricated to house critical structural and mechanical components. Shortly thereafter, the port main engine was installed, ensuring that propulsion systems would align accurately with the stern. Once the stern module was ready, it underwent a flip operation to orient it properly before installation onto the hull. The stern module was then carefully placed and welded into position. Attention then shifted to the bow module. Like the stern, it required a controlled flip before installation. Once adjusted, it was moved into place and joined with the existing hull structure, completing the vessel's forward section. The next major phase involved the superstructure installation, adding strength and form to the upper part of the tug. Finally, the wheelhouse module was lifted and secured, providing the command center that would guide the tug in Arctic waters. By the 28th week of work in Lisbon, the refit team focused on fitting out Boat 8 of the 7.0 project. This vessel, the last to pass through the facility, had a unique construction journey. Its hull was laminated in Persico while the deck was built in France, before both were joined together early in the new year. After initial assembly in Persico, the boat was transported by sea and arrived in Lisbon on April 8th. Since then, the yard has been buzzing with activity. Teams of boat builders, electricians, and engineers worked intensively to complete all detailing and design requirements. Unlike previous boats, this one arrived as an almost empty shell, requiring significantly more effort to install components and systems. The process demanded problem-solving and custom solutions, such as fitting a new speedo in the keel bulb, installing an aerial frame, and mounting new cameras. Altogether, it is estimated that between 500 and 2,000 additional hours were required compared to earlier boats, making this fitting out both challenging and innovative. Transforming Nicole Foss from a raw hull into an impressive vessel required a series of closely coordinated activities. This began with the movement of the hull to the dry dock, where the massive steel structure was carefully positioned and reinforced in preparation for the next steps. From there, the hull was transported to Vancouver, a crucial step that required specialized equipment and logistics to ensure safe passage over long distances. In Vancouver, the project began with the hull launching, in which the vessel was lowered into the water, marking her first contact with the sea. This stage required precision and stability to avoid structural stress. Immediately following, the winch assembly was installed, equipping the vessel with the vital control and towing systems that support operational tasks. The partially equipped vessel was then returned, with the hull transported to Rainier for the next phase of construction. Here, the final structural additions took place, installing the cockpit, completing the ship's shape, and providing command and navigation capabilities. Through these carefully executed steps, Nicole Foss has evolved from a delivered hull into a complete vessel, ready to operate as a powerful and modern vessel. The installation of a Wärtsilä hybrid scrubber system aboard the MV Bothniaborg marked a significant step toward cleaner shipping. Owned by Royal Wagenborg, this ro-ro carrier was equipped with advanced exhaust gas cleaning technology to meet international environmental regulations. The hybrid scrubber system, supplied by Wärtsilä, is designed to operate in both open-loop and closed-loop modes. In open-loop mode, it uses seawater to remove sulfur, while in closed-loop mode, it combines seawater with a chemical buffer, such as sodium hydroxide. This flexibility ensures compliance, even in areas with strict discharge restrictions. K&S played a supporting role, likely contributing through engineering expertise, integration, or related equipment to ensure a smooth installation process. By removing sulfur oxides and particulate matter from the exhaust, the system significantly reduces the vessel's environmental footprint. This project, alongside the similar retrofit of Balticborg, reflects Royal Wagenborg's commitment to sustainable shipping practices. The transportation of a Liebherr LHM mobile harbor crane from Tanvu port to the Nosco shipyard marked a remarkable operation that combined precision engineering and heavy logistics. The Liebherr LHM, known for its impressive lifting capacity and versatility in port operations, required careful planning to ensure its safe relocation. This project showcased not only the scale of the equipment but also the expertise of the team responsible for the move. The operation began at Tanvu Port, where the crane had been stationed for port handling activities. Due to its massive size and weight, conventional transport methods were not feasible. Instead, a specialized heavy-lift vessel was employed to accommodate the structure. The crane was prepared for transport by securing its components and stabilizing it against movement during the voyage. Rigging teams ensured all safety standards were followed, using reinforced lashings and supports to minimize stress on the crane's structure. Once the vessel departed Tanvu port, it made its way toward the Nosco shipyard. Throughout the journey, careful navigation and monitoring were crucial, as the oversized cargo required optimal balance and handling. Upon arrival, the offloading process demanded the same level of precision. Heavy-duty ramps, hydraulic systems, and experienced operators coordinated the safe transfer from the ship to the shipyard grounds. This successful transportation highlighted the close cooperation between logistics experts, marine operators, and engineers. Moving such a large-scale Liebherr LHM crane not only expanded the operational capacity of Nosco shipyard, but also underscored the importance of advanced heavy transport solutions in supporting industrial growth and port development in the region. Fracht successfully executed one of its most remarkable logistics projects, supporting the construction of a fertilizer plant in Louisiana. The scope included transporting oversized components from multiple origins worldwide, with the largest pieces shipped from Shanghai, China. These massive units, measuring 60 meters in length, 7 meters in diameter, and weighing up to 720 metric tons, were first transported by ocean vessel to New Orleans, then transferred by barge to the plant site in Louisiana. The project required extensive pre-planning, technical reviews, and coordination with reliable partners to ensure safe and efficient handling. A major challenge was rolling a combined weight of 1,000 metric tons from a barge over a levee onto the construction site. Fracht's engineering team developed customized trailer configurations and built a special ramp to accomplish this. Thanks to careful planning, global expertise, and strong teamwork, Fracht delivered the components safely and on time, once again proving its excellence in heavy lift logistics. LNG has established itself as the leading provider of floating storage and regasification units, unlocking global operations with a strong track record in safety, reliability, and performance. With over 14 years of average remaining contract length, the company ensures long-term value creation and stability for its stakeholders. A revenue backlog of $6.2 billion further demonstrates its solid financial foundation, positioning LNG as a trusted partner for energy security worldwide. By 2016, the company operated 6 FSRUs with a total regasification capacity of 3.4 billion cubic feet per day. This figure nearly doubled by 2019, with 4 additional FSRUs under construction, increasing the fleet's total regasification capacity to 6.65 BCFD. Such growth reflects the company's ability to respond to rising global energy demand and to deliver projects that meet the highest technical and environmental standards. Ho LNG's in-house FSRU design is one of its greatest strengths, offering modern, competitive, and flexible solutions. Its large fleet provides versatility for diverse market needs, while small-scale LNG solutions expand opportunities in regions with limited infrastructure. The company's focus on operational excellence is supported by a proven track record of delivering safe, reliable, and efficient services. Beyond its technical capabilities, Ho LNG operates with a clear strategy aimed at strong and sustainable growth. Its combination of operational expertise, financial resilience, and innovative fleet design ensures a competitive edge in a fast-changing energy market. As countries around the world transition towards cleaner and more flexible energy systems, Ho LNG's FSRU technology provides an effective bridge by enabling access to natural gas, reducing emissions, and enhancing energy security. With a modern fleet, robust financial platform, and forward-looking strategy, Ho LNG continues to lead the industry as a provider of floating regasification solutions that unlock opportunities and deliver reliable energy across the globe. Container shipping has become the backbone of modern global trade, enabling the movement of goods across continents with efficiency and scale. Among the most impressive examples are the world's largest container vessels, designed to carry massive volumes of cargo while reducing transportation costs and environmental impact. These ships represent a true triumph of engineering, combining size, power, and advanced logistics. Modern mega container ship can transport more than 20,000 TEUs, making it possible to move everything from electronics and textiles to automobiles and industrial equipment in a single voyage. Their length often exceeds 400 meters, nearly the size of several football fields, while their width allows them to stack containers in towering rows above and below deck. Despite their size, these vessels are equipped with highly efficient engines and optimized hull designs to minimize fuel consumption and emissions, supporting greener shipping solutions. The process of transporting goods by such ships involves a highly coordinated system. Containers are loaded at major ports using giant gantry cranes, secured with locking systems, and carefully arranged to balance weight and ensure safety during long ocean crossings. Once underway, the ship follows pre-planned routes that connect global trade hubs, including Asia, Europe, and North America. Upon arrival, containers are swiftly discharged and transferred to trucks or trains, continuing their journey inland. The advantages of container shipping are immense. Large ships lower the cost per container, making international trade more accessible. They also offer reliability, with scheduled services that connect producers and consumers worldwide. Moreover, technological innovations such as digital monitoring, automated loading, and real-time tracking have further increased efficiency and transparency in the supply chain. In conclusion, the largest container ships are not just vessels. They are floating cities of commerce, ensuring that the world's economies remain connected. Their ability to carry vast quantities of goods across oceans underscores their essential role in shaping global trade and supporting everyday life. Container handling operations on merchant ships are among the most critical activities in global trade, ensuring that goods are transferred efficiently between sea and land. The process begins when a container vessel arrives at the port and is securely moored at the quay. Specialized container cranes, often known as gantry cranes, are then positioned alongside the ship. These cranes are designed to lift heavy containers, sometimes weighing up to 40 tons, with precision and speed. The unloading phase usually starts first. Containers stacked on the deck and within the holds of the ship are carefully lifted by cranes, using spreaders that lock onto the container's corner castings. Once lifted, the containers are transferred onto waiting trucks, trailers, or automated guided vehicles that transport them to the container yard for temporary storage. In modern terminals, computerized systems track every movement, ensuring that containers are placed in designated slots for efficient retrieval.
The same purpose, which is to lock containers. Once again, it really is just like stacking Legos. The last thing we want are labor of lashing.
Simultaneously, loading operations prepare export containers for shipment. Trucks and yard equipment bring full containers from storage areas to the quay. Cranes then hoist and stow them into the vessel according to a pre-planned loading sequence, balancing weight distribution and accommodating the ship's route. Careful coordination is required to avoid delays, with terminal operators, ship crews, and logistics companies working together seamlessly. Throughout the process, strict safety measures are observed. Dockworkers monitor crane operations, while advanced sensors and automation reduce human error. Time is also a critical factor, as faster turnaround allows ships to depart on schedule and maintain global supply chain efficiency. In essence, container loading and unloading from merchant ships represent a highly synchronized operation that blends human expertise, advanced machinery, and digital management systems, making it possible for goods to flow reliably across the world's oceans. The Kurt J. Crosby is a powerful 10,000 horsepower ocean-going tug currently operating in New York Harbor. In a notable assignment, the tug was seen making up to the single-point tow chain of the RORO ship Cape Edmond for a tow to Charleston, South Carolina, following the ship's visit to GMD Shipyard in Bayonne, New Jersey. Originally launched in 2000 as the Sydney Candies for Auto Candies Corporation of Louisiana, the vessel was later renamed Kurt J. Crosby. Designed for strength and precision, the tug is driven by 3 electromotive diesel engines. A central 20-cylinder engine powers a fixed propeller on the centerline, while 2 16-cylinder engines positioned outboard drive advanced Z-drive units. This configuration not only generates immense pulling power, but also provides exceptional maneuverability, an essential feature for handling large ships in confined harbor waters or during long ocean tows. With its combination of raw horsepower, reliability, and agility, the Kurt J. Crosby remains a vital asset in modern towing operations along the U.S. East Coast. Marine abrasive blasting is a highly effective method for cleaning and preparing vessels, machinery, and marine structures. Australian Enviroblast specializes in delivering cost-effective and eco-friendly blasting services for ships, boats, and yachts of all sizes. This process is designed to remove rust, corrosion, oil, grease, and stubborn marine buildup that accumulates over time in harsh sea conditions. In addition, it efficiently strips away old paint and protective coatings, leaving surfaces ready for repainting or recoating. Using the advanced Quill Falcon Quick Blast system, Australian Enviroblast ensures thorough cleaning of boat hulls, decks, and marine equipment while minimizing environmental impact. The system combines precision and efficiency, making it ideal for maintaining vessels in peak condition and extending their service life. With proven results across various marine industries, abrasive blasting remains the most reliable solution for restoring and protecting valuable assets, providing vessel owners with both long-term durability and cost savings. The Navijet C300E2 is a versatile electric high-pressure cleaning machine designed to meet a wide range of industrial and marine cleaning requirements. Built to operate with cold water, it accepts feed water temperatures up to 60 degrees Celsius, making it highly practical for environments where hot water is not necessary. Its engineering focuses on durability, mobility, and ease of operation, ensuring reliable performance even under demanding conditions. A key feature of it is its stainless steel construction. The machine is housed in a robust stainless steel frame and enclosed with a stainless steel cover, giving it exceptional resistance to corrosion and wear. This makes it especially suitable for marine applications, where exposure to moisture and salt can quickly damage equipment. The sturdy build also provides a long service life, maintaining both functionality and appearance over years of use. To enhance handling and operator convenience, the unit is equipped with 4 wheels. This design allows users to easily move the machine across work areas, whether on a ship's deck, in a workshop, or in an industrial facility. Despite its solid construction, the machine is engineered to be maneuverable, combining strength with practicality. At the heart of the machine lies a low RPM motor-driven pump. Unlike high-speed alternatives, the low RPM design significantly reduces mechanical stress, leading to longer operating life and minimal maintenance requirements. This ensures continuous reliability and reduces downtime, which is crucial for professional cleaning operations. The pump delivers steady, high-pressure water flow, effectively removing dirt, grease, oil, and other contaminants from surfaces. The Navijet C300E2 is more than just a cleaning machine. It is a comprehensive solution for industries seeking efficiency, safety, and durability. Its cold water system minimizes operational risks, while its advanced design ensures consistent performance. Whether used on vessels, in ports, or within industrial plants, this model proves to be a dependable partner for heavy-duty cleaning tasks. In summary, the machine combines stainless steel durability, smart mobility, and long-lasting motor technology into one professional-grade unit. It represents a perfect balance between performance and longevity, offering users an effective and cost-efficient high-pressure cleaning solution.